Hello, everyone. In this particular class, we're going to look at polar form or trigonometric form of complex numbers. Okay, so you can see here that the polar form of z, which is equal to x plus iy. Now, this z equal to x plus iy, we call it the complex form. And the polar form is written as this: z equal to r into cos theta plus I sin theta. It's just another form of writing it, but they are all the same thing. Okay, so r here is square root of x squared plus y squared, and theta is tan inverse of y over x. Now the r is called the modulus and theta is called an argument. So don't forget that z is equal to r into cos theta plus I sin theta. That's the polar form. The r, like I mentioned, is called the modulus, and the theta is called the argument. So we see an example here. We're asked to write the polar form of this particular equation, this particular complex number. Now we start by saying r, finding r, that's for the first one. Now for I, r is equal to square root of 2 squared plus 2 squared, because both the real part is 2 and the imaginary part is 2. Okay, so that is going to give us square root of 8, so root 8. Or if we like, we say 2 root 2. Converting that to simplifying that solved. Then what is theta? Theta is equal to the tan inverse of the imaginary part all over the real part. So in this case now, we tan inverse of 2 over 2. And 2 over 2 is 1. Okay, so you have tan inverse of 1. And tan inverse of 1 is what? 45 degrees. Now in this case, you must know how to, most times we leave our theta in radians. So you must know how to convert degrees to radians. How do you convert degrees to radians? You multiply by pi over 180. So that means 45 degrees is the same thing as 45 times pi over 180. Okay, and that is going to give us pi over 4 radians, because 45 can go in 180 4 times. So you have pi over 4 radians. Okay, so that means my polar form now will be written as z equal to r into cos theta plus I sin theta. So your r now is 2 root 2 into cos theta. Your theta now is pi over 4. Okay, plus I sin theta, which is pi over 4. So that is the answer to that question. That's the polar form for that first equation. I want to believe that that is easy. Okay, so let's see the second one. We have this 1 plus I root 3. First of all, we find r. What is r? R is square root of 1 squared, that's for the real part, plus root 3 squared, that's for the imaginary part. Okay, so that will now be square root of 1 squared is 1, root 3 squared is 3, because the square just cancels the root. So that will give us root 4, and root 4 is 2. So that's our value for r. Our value for theta will be tan inverse of imaginary part over real part. That means root 3 over 1. Okay, the imaginary part is root 3, the real part is 1. Okay, so and tan inverse of root 3 is 60 degrees. If I multiply 60 degrees by pi over 180, that's converting it to radians, it's going to give me pi over 3 radians. Okay, so that means my polar form, the polar form of that very complex number is 2, which is your r, into cos theta, which is cos pi over 3, plus I sin theta, which is sin pi over 3. That gives us the answer to that question. That is quite easy. Okay, so I want you to do this for me. The first one is to write the polar form of I, 2i root 3 plus 2. Then secondly is 8i. Okay, please correct the first one. Not 2i root 3 over 2. Make it 2 root 3. Okay, then plus 2i. Sorry for that. 2 root 3 plus 2i. Okay, then secondly, just 8i. So I will be needing your answers quickly. I want to see the first 5 persons to submit.